All right, so in this video, we are going to factor these polynomial equations over here, and we're going to do it using factor theorem and synthetic division. So let's get started. We have our x to the power of 4 equation here, a quartic equation. You want to find a perfect factor that divides into this. So in order to do that, we need to sub in multiples of the first number times the last number, although since this number is so big, I'm not really going to worry about this first number over here. I'm going to sub in multiples and see what we get. So I know that positive 1, positive 2, positive 3 are all multiples of 270. So those are the first three numbers I'll test. Let's start with positive 1. So I'm going to replace x with 1 in this equation. And I'll do this in my calculator. And I get positive 180. So I know that x minus 1 is not a factor because it has to equal to 0 to be a factor of this equation. So if 1 doesn't work, I'll go to positive 2. But put in positive 2, I get 28. So I know that x minus 2 is not a factor either. So I'll go to positive 3 next. So I do get f of 3 equals to 0, which means x minus 3 is a factor of this equation. So now I can go to synthetic division, simplify the equation a bit. So I'm going to put this number out over here, and I'm going to put all the coefficients of my equation on the top over here. So 4, 7, negative 80, negative 21, 270. I'm going to start by just bringing the first number down. Then I'm going to multiply these two numbers to get the next one here. So 4 times 3 is 12. I'm going to add these two numbers, 19. I'm going to follow the same process. So 3 times 19 is 57. Add these two numbers is negative 23. Multiply these two. That's negative 69. Add these two, negative 90. Multiply these two, negative 270. Add these two, and you should get 0 as the final answer because the remainder here is 0. If you don't get 0 here, it means you made a mistake. So now let's write this in partially factored form. I know that my first factor is x minus 3. And then these are the coefficients of my next equation here. If I have a quartic equation and I factor it one time by synthetic division, this will turn into a cubic equation, and these are all my coefficients. This is going to be 4x cubed plus 19x squared minus 23x minus 90. So now I need to factor this even further. I need to factor this cubic equation, and since it's cubic, I need to do factor theorem and synthetic division again. Now I know positive 1 and positive 2 didn't work for the first equation, so it's definitely not going to work here. Positive 3 worked and gave me a solution. Positive 3 can work again. You could sub in, there could be two factors of x minus 3 for any equation, but it's very rare. So what I'm going to do is I'm going to sub in negative multiples of this number now. So I'm going to start with f of negative 1, and if that doesn't work, I'll try negative 2 and negative 3. So if I put negative 1 in this equation, get negative 52. So that's not a good factor. Let's try negative 2 next. If I sub in negative 2, I get 0. So I know now this is a perfect factor. So I can do synthetic division Again, -2 out here, that number, and then the coefficients of this equation are 4, 19, -23, -90. Follow the same steps, bring that down, multiply those two, add these two, multiply those two, add these two, multiply those two. Final solution should be 0 because our remainder is 0. Now I can write this in an even more factored form. I'll start by writing the first x minus 3, which was already there. Then for this -2, it is x plus 2. And then the cubic equation will turn into a quadratic equation. And these are my coefficients here. 4x squared plus 11x minus 45. Once it turns quadratic, you can just factor it with your regular factoring methods. In this case, it's a complex trinomial, and I'm factoring it with man method. So what multiplies to -180 and adds to 11? It's not going to be 18 and 10. Probably 20. Yeah, 20 and -9. Two numbers and multiply that and add to this. Now I'll break this down. 4x squared plus 20x minus 9x minus 45. I'll split it in the middle. Common factor is 4x, x plus 5. It's -9 here, x plus 5. And then I'll common factor out the x plus 5, left with 4x minus 9. So now I can write my final solution here in factored form, which is x minus 3 times x plus 2 times x plus 5 times 4x minus 9. Go to the second example over here. There's 3 examples in this video in total. In this second example, if I take a look at this, I actually have a common factor over here. So my first step is I want to common factor out an x. Then I want to do factor theorem. So multiples of 30 are, you can start with positive 1, 2, and 3. So let's start with f of 1. If I sub in 1 into this equation in here, you don't really need the outside. 1 to the power of 4 minus 5, 1 power of 3. Get positive 48, so that doesn't work. Let's try f of 2 next. Get 36, so that's no good. Let's try f of 3 next. And f of 3 is 0 for this one, so I know 3 is a perfect factor here. So I'll do 3 and I'll write my coefficients. Do my synthetic division. Then I'll write my equation in factored form. I first have my x, then I have x minus 3 for that one. And then the quartic equation turns cubic, so I have x cubed minus 2x squared minus 13x minus 10. I want to test out these values as well. So now I'll do negative numbers because I tried the positive ones. So let's start with -1 in this equation. So -1 to the power of 3 minus 2 times -1 squared minus 13 times -1 minus 10 is 0. So just need one calculation there. -1, 1, -2, -13, -10. Let's do a synthetic. Now I can write this in further factored form. So x minus 3. And for this one, I have x plus 1, and now this is a quadratic equation, x squared minus 3x minus 10. This is a simple trinomial. So what multiplies to negative 10 and adds to negative 3? It's just negative 5 and positive 2. So x minus 3, x plus 1, x minus 5, x plus 2 is the final solution. Let's go to this third and final question for this video. Again, there's honestly no difference in difficulty in this one, so you probably already know how to do it. I think you can try it yourself and just make sure you get the same answer as me. Make sure you make no silly mistakes, but there's no common factor in this one, so I'm going to start with multiples of 144. I'll start with positive 1. Get positive 100. I'll change that and try 2 now. Get 36. I should try my next multiple, which is 3 in this case. And if I sub in 3, I will get 0 over here. Since f of 3 is 0, I can do my synthetic division. 3, 1, 2, negative 23, negative 24, 144. Now I can write this in factored form. So x minus 3, and this is going to be cubic. X cubed plus 5x squared minus 8x minus 48. I'll do synthetic on this again. So since I tried positive 1, 2, 3, I'll try negative 1, negative 2, and negative 3. So negative 1 to the power of 3 plus 5 times negative 1 squared minus 8 times negative 1 minus 48. Negative 36, that doesn't work. So let's try negative 2. Negative 20 doesn't work either. Let's try negative 3. Negative 6. So none of these are working, but as I notice, I'm getting closer to 0. So next multiple is actually positive and negative 4. Let me test negative 4 first. And if that doesn't work, I'll try positive 4. But negative 4 does look like it's probably going to work because as you can see, the numbers are getting closer and closer to 0. And f of negative 4 is 0. I'll do my synthetic again. Negative 4, my coefficients are 1, 5, negative 8, negative 48. Do my synthetic. And my remainder is 0, so I know I'm definitely right. I'll write my first factor, x minus 3. I'll write the factor for this one, which is x plus 4. This is now quadratic, x squared plus x minus 12. Now I'll factor this with man, so 1 multiplies to negative 12 and adds to positive 1. That's just positive 4 and negative 3. So I have x minus 3 times x plus 4 times x plus 4 times x minus 3. So this is actually a question where your factors do repeat. But luckily, it is possible to still figure it out without repeating the same number. But if I put f of 3 in this equation over here, again, I would have got 0. And rewrite this as x minus 3 squared times x plus 4 squared.